In our first tutorial, we looked at how to use JavaScript to render a simple tile map to a canvas element on a web page. In this tutorial, we'll expand on that by adding a character which the player can control around the map using the arrow keys. We'll begin by adding some additional global variables. First of all, last frame time, which will keep track of the time the last frame was drawn in milliseconds. Also, keys down, a map which will map the event codes of the arrow keys on the keyboard to Boolean flags for whether or not the keys are currently pressed down. To begin with, all of these values will be false, and we'll be storing values for the numbers 37, which is left, through to 40, which is down on the keyboard. We'll also create another global called player. This will be a new instance of the character class, which we'll create in a moment. Although we'll currently only be drawing one character on the map, the character class will allow us to easily create additional characters in the future when we need to do so. The character class will keep track of the character's current tile position, the destination tile of the character, the time at which movement began to the destination tile, the dimensions of the character in pixels. We'll be using 30 pixels wide by 30 pixels high for this example. The exact position of the character relative to the top left corner of the map in pixels. And the time it will take the character to move exactly one tile in milliseconds. We'll be using 700 milliseconds or 0.7 of a second for this example. The character class will have a placeAt method. This method will immediately place the character at the destination tile. It will take two arguments, the X and Y position of the tile on which to place the character. It will begin by updating the tile from and tile to properties of the character to the target X and Y values. We'll then calculate the X and Y pixel position of the character. We'll do this by multiplying the width of the tile, width of a tile, by the X value. And to this, we'll add the width of a tile, subtracting the character's width, and dividing this by 2. Similarly, for the Y position, we'll multiply the height of a tile by the Y value, and to this, we'll add the tile height, subtracting the character's height, divided by 2. Next, we'll add the process movement method for the character object. The process movement method will take one argument, the time elapsed currently in the game, t. It will return either true or false depending on whether or not it's had to do any processing. If movement is ongoing, it will return true. However, if the character is not moving at all, it will return false. To begin with, inside the method, we check and see if the destination tile, tile 2, is different to the current tile, tile from. If either the x or y values of tile 2 or tile from are different, then we know that the character is currently moving. If, however, they are both the same, then we know that the character is currently at its destination tile, in which case there is no movement processing to be done, and we can return false from this function. If we've determined that the character is currently moving, we first of all check and see if the amount of time elapsed since the character began their movement is greater than or equal to the time it takes the character to move one tile. We calculate this by subtracting the time moved for the character, the time at which the movement began, from the current time, t, and seeing if this is greater or equal to the delay move value we've set for this character. If this is the case, then we know that the character has had long enough and should have reached its destination tile. We call the placeAt method for the character, and hand for the x and y arguments the x and y values of the tile 2. Otherwise, we're going to need to calculate the current pixel position of the character on the map. We begin by calculating the pixel position on the map of the current tile for the character in the same way we do for the placeAt function. The x position is calculated first. We calculate this by multiplying the current tile position x value by the width of a tile, and to this we add the width of a tile subtracting the width of the character divided by 2, and similarly for the y position we multiply the current y position, y tile of the character, tile from, by a tile height, and adding the height of a tile subtracting the height of the character divided by 2, and this will give us the pixel position of the character at their starting tile, the tile from value. We then want to modify these values based on which dimension the character is currently moving in, whether they're moving horizontally or vertically. So first of all, we'll check and see if the character is moving horizontally. We'll check and see if the x value of the character's tile 2 is different to the tile from x value. If this is the case, we know the character is moving on the x-axis, they're moving horizontally. If so, we'll calculate diff. Diff will be the distance moved in pixels between the current and destination x values. And we'll calculate this by dividing the width of a tile by how long it takes the character to move one tile, the delay move. And we'll multiply this by the amount of time that has elapsed since the character began moving, in other words t minus this dot time moved. We'll then either add or subtract this value from the current x position. So we do x position, the position x value, position x, plus, and then we see if the destination tile is to the left or to the right of the character's current position. So if this dot tile 2 x value is less than the tile from x value, then we know that the character is moving to the left, so we need to subtract this value, in which case we will do 0 minus diff. This will give us the inverted diff value, the negative diff value. Otherwise, we'll simply be adding diff, as was calculated. We want to do similar for movement on the vertical axis. So if this tile to y value is not the same as the tile from y value, again we will calculate diff. This time we'll do tile height divided by the delay move for the character, the time it takes them to move one tile, multiplied by the amount of time that has elapsed since the character began moving. And we will either add or subtract this from the character's position y value, position index 1. And again, to see if we need to subtract or add this value, we check and see if the destination y value is less than the current y value. If it's less, then we're subtracting this value, so we do 0 minus diff to get the negative value, the inverted value of diff. Otherwise, we simply use diff as it is in its positive value. After doing these calculations, we will round the position values to the nearest whole number. We can also return true from this function. We'll only return false if no processing has been done whatsoever for the movement. If we've got this far, we know that some movement processing has been done. We'll also add a helper function called toIndex, which will take two arguments, x and y, which is the x and y position on the map, and it will return the corresponding game map array index. It will do this by multiplying the y value by the map width and adding the x value. We now want to add some additional event listeners to the window onload function. The first of these event listeners will listen for the key down event. This event occurs whenever a button on the keyboard is pressed down. Now, if the key code of the event is between 37 and 40, then we know that one of the arrow keys was pressed. If this is the case, then we want to update the keys down map to set the Boolean flag to true for the corresponding key. We'll add another event listener for the key up event. This occurs when the key is released. Again, we check if the key code falls between 37 and 40, in other words, if it corresponds to one of the arrow keys on the keyboard. If this is the case, we update the keys down map correspondingly to false. Now we'll update the drawGame method. First of all, we'll create a temporary variable called current frame time, to which we'll assign the current time in milliseconds. We'll also create a temporary variable called time elapsed, which will be the elapsed time since the last frame time in milliseconds, calculated by subtracting last frame time from the current frame time. We won't be using this currently beyond simply creating the variable, but it will be useful in future lessons. Now, after the calculations for the frame rate, we'll check and see whether or not the player is processing any movement. We'll call the process movement method for the player character with the current frame time as the time elapsed for the argument. If the method returns false, then we know the character is not currently processing any movement, so we will now check and see if any of the arrow keys are pressed down and if the character can move in the corresponding direction. For each of the directional arrow keys, we'll check first of all and see if the key is held down, and then we'll check and see if the tile in that direction from the player's current position is A, within map bounds, and B, in the game map array if the corresponding value is 1 if it's a path tile. If either the tile is out of bounds or the value in the game map array in that direction is 0, then we will not allow the character to move there. First of all, the up arrow key. We check and see if the tile from Y value is greater than 0. If it's 0, then trying to head upwards from the current position would put the character out of map bounds. We then get the value of the game map array at the corresponding index of the tile directly above the player's current tile. We use the X value from the player tile from, and the Y value for the player tile from we reduce by 1. This gives us the tile directly above the character's current position. If the value of this is 1, we know that this tile is a path tile, and so can be moved to. If these checks are all true, then we know that the character can move to the destination tile. In this case, we set the tile to Y value reduced by 1. If the down arrow key is held, then we need to check and see that the player tile from Y value is less than the height of the map minus 1. We will also check the index at the game map array corresponding to the current X value of the tile from for the player and the player's tile from Y value plus 1. If these checks are all okay, then we'll increase the tile to Y value by 1. Movement on the horizontal axis with the left and right arrow keys is done in a very similar fashion. First of all, if the left arrow key number 37 is pressed, we check if the tile from X value is greater than 0, and we also check if the game map value at the index to the left of the current tile from value is 1, is a path tile, in which case we modify the tile to X value to reduce it by 1. If the right arrow key is pressed, key number 39, we check that the tile from X value is less than the map width minus 1, and that the game map value at the index tile from X value plus 1 with the same tile from Y value is 1, is a path tile, in which case we increase the tile to X value by 1. After checking for arrow keys being pressed in order to process new movement for the player character, we check and see if the tile from values are the same as the tile to values. If the tile from X value does not match the tile 2 X value, or the tile from Y value does not match the tile 2 Y value, then we know that the character is currently moving. In which case, we update the player time moved value to the current frame time, as this is the time at which the movement has begun. Now we can draw the player character on the map. After our nested drawing loops for drawing the map tiles, we'll change the fill colour to a nice bright blue. We'll then draw a filled rectangle at the player's position, X and Y values. And the width and height of the rectangle will be the player dimensions. Finally, before requesting the next animation frame for the game, we'll update the last frame time global to the current frame time. If you followed the instructions correctly, you should now see the tile map drawn to the canvas as in the first lesson. However, now there will also be a blue rectangle representing the player character, which can be controlled around the map on a tile-by-tile basis using the arrow keys. In the next tutorial, we'll look at drawing tile maps which are larger than the canvas area and using a viewport to draw only a portion of the tile map and culling to make sure we don't do any unnecessary drawing of tiles that are off the screen.